Hi guys, welcome to Unit 8, Lesson 2. I am recording this for Friday's May 15th math class. This is kind of a tricky lesson to do on a YouTube video just because it really wants us to discuss things and whatnot. So I'm going to modify this lesson and take some stuff out. Okay, before we begin, our learning targets are: I can tell statistical questions from non-statistical questions and explain the difference, and I can tell when data has variability. So there's two main vocab words we're going to learn today, which is variability and statistical questions. These are going to make more sense towards the end of the lesson, but really quick, a statistical question is a question that produces numerical data. So remember data that are numbers like 2, 10, 16, 17, 25. That's numerical data. It's numbers with variability. So the word variability means that there's a lot of difference in the data. So for example, if I gave you the list 2, 2, 3, 2, 2, 3, that does not have a lot of variability. It has a lot of the same numbers. But if I gave you a list of data that was like, let's see, 2, 300, 16, 32, 81, that data has a lot of variability, a lot of difference. So that's just kind of quickly what those words mean. So statistical questions produce numerical data with variability. We're going to get into that now. I'm actually going to have you guys skip 2.1 completely, because lesson 2.1 is just not, like, we can't really do that on our own because it involves all of us collecting data. So let's just go ahead and start with 2.2. What is in the data? It says that 10 sixth grade students at a school were each asked 5 questions. Their answers to each questions are shown here. So this is data set A, this is data set B, etc. It says that right on the side. And then it gives us the numbers that were collected from those students. So I'm going to go ahead and turn the page. Before we answer the questions about this data, I want you to notice that data B has no variability, right? You get the same number from each student. Data E, however, has a ton of variability. You get a lot of different numbers. I don't think there's any repeating numbers in data set E. So I want you to think about that and use that to help you answer these questions. So here we have 5 survey questions, and we're supposed to match the question to the data set that could represent students' answers the best. Explain your reasoning. So question 1 says to flip a coin 10 times. How many heads did you get? So you're asking 10 different students this questions. So think about the possibilities. Maybe one student flipped the coin 10 times and got 0 heads. Maybe they flipped the coin 10 times and got 10 heads. Those are possible, but it's more likely that it's about half and half, right? So go ahead and look at the data set. Which one do you think makes the most sense? Pause the video and unpause it once you figure that out. Okay, I think looking at the data, that data set C makes the most sense for this one. My reasoning for that is that the numbers 6, 5, 7, 6, 4, 5, 3, 4, 6, 8 are all in the middle range. So most likely when you flip heads or tails, you get kind of in the middle, 50-50. And so I think that one makes the most sense. The numbers range from 3 to 8. We of course could have 2 or 1, but most likely you're going to get at least some heads or some tails. Okay, question 2. How many books did you read in the last year? So just thinking about that question, and students, there's going to be a lot of variability in this question. So some students may have read a ton of books. Maybe you're a huge reader. Maybe you only read one book in the last year. So I think this question is going to be one with the most variability, or a lot of variability. So if you look at data set A, probably there's students that have read more than 3 books. So probably it's not that one. Data set B, I think it's very unlikely that all students read 12 books. Probably not. Data set C, well, we already used that one, so we know it's not going to be C. Data set D also has no variability, right? I don't think that it's likely that every single student read 6 books. That just doesn't make sense. So by process of elimination, I think we can agree that data set E makes the most sense. Some students only read 2 books. One student read 16, one student read 11. So this one makes the most sense with the question. So I'm going to put question 2 is data set E. All right. Let's look at the next question. What grade are you in? Okay, if you're asking everyone in our class that grade, you get the same answer, right? Remember, 10 6th graders are asked this question. So that right there tells you what grade these people are in. And so because of that, we can put data set D for that one, because we already know that they are all going to answer with 6th grade. That question has 0 variability because you asked all the students in the same grade what grade they're in. Okay, question D. How many dogs and cats do you have? Okay, so you're asking 10 people how many dogs and cats they have. Most likely they're going to have different numbers, and so it's probably not going to be B. And so that only leaves us with one other possibility, which is data set A. Data set A makes sense as well, because a student could have 0 cats and dogs. That's common. A couple students could have 1. A couple students could have 2. A couple students could have 3. That all makes sense. So data set A could represent dogs and cats. Probably if data set A had a number like 200 in it, that would not make sense, right? Because it's not very likely that anyone's going to have 200 cats and dogs. Okay, question 5. How many inches are in a foot? Okay, we know there's only one other data set left, but we know that there are 12 inches in a foot, and that's not going to change. So every student said 12, and that is the correct answer. And so we're going to pick the data set with no variability that just says 12 over and over again. Okay. Question 2 says, how are questions 3 and 5 different from other questions? Okay, so 3 and 5 are what grade are you in and how many inches are in a foot. So this data set and this data set, how are they different from the rest of the data sets? Take a second to think about that. The answer is that these are questions that have no variability. And because they have no variability, they are what's called a non-statistical question. So in order for a question to be considered a statistical question, there needs to be variability. There needs to be differences in your answers. And data sets B and D, or questions 3 and 5, they have no variability. They're just questions that are going to give you the same answer. Okay, moving on to 2.3. What makes a statistical question? So here we have 3 questions that are statistical, and then on the other side we have questions that are not statistical. So I'm going to put a check here, and I'm going to put an X here. So 3 questions that are statistical are, what is the most common color of cars in the school parking lot? So you might have 5 white cars, 10 blue cars, 18 gray cars, you're going to have a lot of different answers that are numerical. What percentage of students in the school have a cell phone? Okay, so you're going to have different answers there for students that don't and students that do, and you're going to get a number answer. And then what kind of literature, fiction or nonfiction, is more popular among students in the school? So that's also a question you could go around asking. Now, for both the second questions, those are likely not going to give you a ton of different answers, right? You're going to have students that have cell phones and students that don't. And then you're going to have students that like fiction or students that like nonfiction. That's okay. But they're still going to give you data, right? Let's look at questions that are not statistical. What color is the principal's car? Okay, I could answer that with one answer. Blue. So I can't graph that, right? That's just a one-word answer. Does Elena have a cell phone? No. Okay, that's also a one-word answer. You can't graph it. What kind of literature, fiction or nonfiction, does Diego prefer? Fiction. So in non-statistical questions, you get one-word answers. You cannot graph the data that you receive from those questions. Okay, so we can't have this class discussion because we're not together right now, but let's go ahead and look at the questions. How are the three statistical questions alike? What do they have in common? Well, they're all asking questions that are going to give you lots of different answers, right? You're going to know how many different cars there are for each color. You're going to know how many students have a cell phone, how many students don't have a cell phone, and you're going to know how many students like fiction and how many students like nonfiction. How are the three non-statistical questions alike? What do they have in common? Okay, well, we went through that. They all are giving us answers that are one word, right? So you cannot graph those answers. You're going to ask the question and then you're going to be done. How can you find the answers to statistical questions? How about answers to non-statistical questions? Well, in both cases, you would go around collecting data, asking people things. You could survey people. With non-statistical questions, it's a lot easier maybe to just observe. Like you could observe what the principal's car is. But yeah, there's many different ways that you could figure out each. What makes a question a statistical question? Like we said, you can graph it and it has variability and it's often numerical. So you can count how many for each answer. Okay. Read each question, think about the data you might collect to answer it, and whether or not you expect to see variability in the data. So remember, variability means difference. How many cups of water do my classmates drink each day? Is variability expected? Is the question statistical? Well, let's think about it. Okay, maybe Vanessa drinks 10 glasses of water. Maybe Logan drinks 3 glasses of water. Maybe Asher drinks 1 glass. Maybe Jesus drinks 5. So, sorry if you didn't like that I called you guys out. I just thought of random kids in the class. But you probably would get a good amount of variability in the data to an extent. Probably you're not going to have a lot of kids drinking more than, 5-8 glasses of water a day. But you are going to get different answers. So your answer is yes, there is variability in the data. And yes, it is a statistical question, because we could take that and we could create a dot plot or a different kind of graph to answer that question. Okay, where in town does our math teacher live? Okay, well, I'm your math teacher, and I live in Santa Barbara. So I just gave you that answer. So there is no variability, right? I only live in that one place. And it is not a statistical question because it's just one word answer. You can't graph that. How many minutes does it take students in my class to get ready for school in the morning? Okay, well, let's think about it. Maybe it takes some of you 15 minutes, maybe 20 minutes, maybe a half an hour, maybe an hour, maybe an hour and a half, maybe 2 hours. This is a question that is going to have variability because you probably all don't take the same amount of time getting ready, and you could graph the answers. So yes, it has variability, and yes, it is a statistical question. That's a hard word to say, by the way, statistical. Okay. How many minutes of recess do 6th grade students have each day? Well, you all are in 6th grade, and before coronavirus, we all had the same amount of recess time. So if you're just looking at our school, you're not likely to find any variability, right? We all have the same amount of recess. So no. However, if you are looking at all the different schools in California, maybe you would have variability and it would be a statistical question because maybe schools in Lompoc all get 20 minutes and schools in Santa Barbara get 10 minutes and schools in LA get 30 minutes. In that case, it could be variable and it could produce statistical data. But if you're just looking at the 6th grade students at Los Barros, no, we all have the same amount of recess time. Okay. Do all students in my class know what month it is? Okay, so let's think about that. That's a question you could ask, and you're either going to get yes or you're going to get no. So it's only a 2-category question. So because of that, you're not going to get a lot of variability. You will get some. You're either going to get yes or no. But I'm going to put no for variability. And then is it a statistical question? Well, you could graph it. You could graph yes or no. So for that, I could say yes. However, it's not going to be a very good statistical question because your graph is going to be pretty boring. It's probably going to look like most of the students in the yes column, right? I think most of you know what month it is, and maybe 1 or 2 of you don't. Okay, so it's not a very good question, but it is technically statistical. Okay. That is all for today's lesson. I know that was pretty quick. I did skip 2.1 because we're not all together. But if you have questions about statistical questions, we are going to talk more about them on Monday, so don't worry too much about statistical or non-statistical questions if you're super confused. Remember our learning targets where I can tell statistical questions from non-statistical questions and explain the difference. And then B is I can tell when data has variability or difference. So hopefully you're able to see if you made those learning targets or where your understanding is in its progress. Go take the cool down posted, I believe, on Google Classroom. That way I can see where your understanding is. All right, guys, I hope you had fun today at electives. If you're watching this on Friday and at PE, yeah, have a